Okay, so in this video, we're going to take a look at productivity questions. Um, I'm going to go through a series of questions that are pretty typical for productivity, and this might be the types of questions you'd see on an exam or on an assignment if you're taking an operations management course. So some of them are fairly straightforward, other of them are a little trickier. So let's go through, let's start here. Here's the basic premise. Buddy's Bats is considering two locations for a new plant. The plant will produce 500 bats per week. Fixed setup costs are identical. Not worried about fixed costs is the bottom line there, because they're the same in both plants. Plant A can make 500 bats, 8-hour shift with 5 staff, 5 days per week, 25 bucks an hour, 600 units of maple at $5 per unit, and overhead at $1,000 per week. Plant B is 500 bats, 8-hour shift with 7 staff, 5 days a week, $20 per hour, 625 units of maple at $4 per unit, and overhead of $1,500 per week. So the first question we're going to ask is, what is total cost of production and cost per bat? What is labor cost per bat? This is pretty straightforward. It is simply the totaling the cost. So total cost, plant A, total cost is equal to 1,000, which is overhead, plus 600 times 5, which is material, plus 8 hours times 5 staff times 5 days times $25 per hour, and this is labor, is equal to 1,000 plus 3,000 plus 5,000 equals $9,000. Cost per bat is equal to 9,000 divided by 500 is equal to $18 per bat. Labor cost per bat is equal to 5,000, which is taken from there, divided by 500 equals $10 per bat. Pretty straightforward. And we can do the exact same thing for plant B. Total cost is equal to 1,500, which was the overhead, plus 625 times $4, which is the material, plus 8 hours times 5 days times 7 staff times $20 per hour is equal to 1,500 plus 2,500 plus 5,600 equals $9,600 for a week for 500 bats. Cost per bat is equal to 9,600 divided by 500 equals $19.2 per bat. Labor cost is equal to 5,600 divided by 500. 5,600 is this labor cost, is equal to $11.20 per bat. So this is just simple accounting type stuff. You've figured it out. I think it's it's worth looking that even though labor cost per hour was higher uh, they needed fewer people, uh, and so the total labor cost is higher at plant B. That's one of the reasons we do productivity calculations. So now the next thing we're going to ask is calculate and compare labor productivity. Now, you could do this by hours, and you would have 200 hours at plant A and 280 hours at plant B, and you would calculate your labor productivity per hour. But that's difficult to calculate in this case, or difficult to compare in this case, because it doesn't account for the difference in the wage rates. So could do by hour, but more difficult to compare. So per dollar of labor is more accurate. So let's look at a per dollar. We look at plant A. Labor productivity is equal to 500, which is output, divided by 5,000, which, as you recall, was the labor cost, 5,000 from plant A. So input of 5,000 labor dollars equals 0.1 units per dollar. Plant B is equal to 500 divided by 5,600 equals 0.089 units per dollar. Now, I've calculated them just as you would uh, uh, output measures or productivity measures. If you look that the cost per bat for plant A was $10. Labor cost per bat was $10. So the labor productivity would be the inverse of that. So you get the same answer. If you weren't asked to calculate total cost as part of the question, then this is the way to do it here. But generally, I just wanted to show you the equivalence. So in this case, plant A is more productive per labor dollar. A bigger number is better than a smaller number. So the next thing we can look at is what's called multifactor productivity. And for multifactor productivity, we look at all of the factors that we're putting into production because sometimes we might have good labor productivity, but we have more expensive materials or whatever. So in this case, for plant A, we have output. Multifactor productivity is still output, which is 500. Well, let's do it. Output over total cost in dollars. And so you could do the total cost, but we've already calculated it. So it's 500 over 9,000 equals 0.056 bats per dollar. This number should be should be smaller than this number because you have the same output on the top, but you should have more dollars on the bottom. So it's 0.056 for plant B. Multi-factor productivity is equal to 500 bats divided by $9,600 is equal to 0.052 bats per dollar. Now, in this case, both of the plants could produce the same number of bats. So you could have looked at just the dollars and said plant B is less productive than plant A. But if we had different levels of output, which is an easy thing to add, then then we would have had to do the calculations just like we did. So again, in this case, plant A is preferred. So next question is, what other factors, the data can give you insight, but it can't make decisions for you. So what other factors might the management team consider before choosing consider before choosing a location? And there could be lots of them. Access to markets. We didn't look at transportation costs at all. Access to inputs, the regulatory environment. I only talked about dollars per hour. I didn't talk about benefits and sort of those. We could look at environment, labor laws, and other factors. We could look at shipping costs. That's related to these ones. Tax rates, other infrastructure. What are the roads like? What are the supporting industries like? Corruption, especially in the developing world. Exchange rate risk. In this case, we did calculations that looked at we looked uh, at similar dollars. We didn't look at exchange rate risk. That's another thing. Political risk. How stable is it? And there could be others. So that's the type of thing you would put if you were asked that question. The last question is, Plant A's manager believes he can increase labor productivity by 10% by increasing wages to $26 per hour. How many bats can they now make in a week? What is the total labor cost per bat? And total cost per bat. How much have each improved? So in this case, the question isn't clear on how to calculate productivity. You can use either hours or dollars, but answers were. So in this case, you can use either because I didn't state the question clearly. I did that on purpose just to show you that if I'm not clear, there might be multiple ways, and you'd get credit for multiple ways. So let's look at it using hours. Using hours, previous productivity was 2.5 bats per hour. Increase by 10%, 2.75. So we now know our productivity is 2.75. We don't know how many bats we can produce. We do know we use 200 hours. So we're not changing the shifts. We're not changing the shifts, right? So then we would solve. So they still work the same number of hours. We're just paying the people more, and they're making more output. So in that we solve for, and we get 550 bats per week. Labor cost in total is equal to 200 hours times now $26 times $26. Sorry, my pen was acting up. $26 is equal to $5,200. So our labor cost has gone up, but it's gone up less, so that our $5,200 divided by 550 bats, remember our production went up, is equal to $9.45 per bat, which is actually cheaper. So when we could do 10 minus 9.45 over 10 is equal to a 5.5% improvement in productivity. If we then look at total cost is equal to 1,000, so overhead hasn't changed. This is where there's a trick. We now are going to use more wood because we haven't changed the wood productivity. So we're just adjusting that up by the amount that we have increased our bats. Uh, more material because more bats. Plus $5,200 equals $9,500. So total cost per bat, $9,500 divided by 550 bats is equal to $17.27 per bat. 18 minus 17.27 divided by 18 equals 0.0422 equals 4.22% improvement. So paying people more helped. Alternatively, or we do it by dollars, 0.1 units per dollar increase by 10%, 0.11. 0.11 equals x over 200 times 26 equals, x is equal to 572. So in this case, we can make 570 total labor cost stays at $5,200. From there, divided by cost per bat is equal to 5,200 divided by 572 is equal to 9.09, which would come out to a 9.1% improvement using the same approach I used last time. So that is very quickly an overview of productivity. Productivity is really just output over input. Think about if you're comparing two different places with different input costs, either labor costs or material costs, you should convert it to dollars. Multi-factor productivity, you need to convert to dollars, and otherwise it is a relatively straightforward process. There you go.